Hello. Hopefully this has gone live, and yeah, we'll be going into doing some stuff. I do not know who we've got here, but I'm sure it will be quite interesting. Right, so just get myself ready. Excellent. I can be heard, yes? Anybody hear me? Am I? Yes, okay, we got an answer. This is good, this is good. All right. And seen, even better. Cool, all right. So we've got some slightly better software this time, hopefully, so things should flick around and we shouldn't lose anything. Right, so last time I was porting the DARM library. So here we go. This is what we created last time. It is a ARM disassembler, which built into some tools and then made into a small debugger module. Nothing special, just something that could at least do disassemblies. So today we're going to expand that a little bit more and try and make it into a more expansive version of the debugger by adding in the extra facilities for dumping memory and some of the other bits and pieces that the debugger needs. So that means updating the module to have some extra commands, and I can't remember what those commands are, so I'm going to have a quick look. So down here, fortunately, where I left the debugger module, it's actually got a list of all of the commands that the module provides, which is quite handy. So I suspect I'm going to do star memory, MemoryA, MemoryI. So that's displaying memory with some parameters, display as a hex dump and the like. Altering memory, I'll see if I want to do that one. It's not generally that useful. Disassemble we've already done. Probably do show regs as well. Not sure I'm going to do these other ones up here that cover the debugger type operations. We'll have a see whether we do those or not, because the debug interface is not particularly great in debugger. I mean, that's the other thing, is once we've got something, we could actually make it much more powerful. So we might look at that in the future. Okay, for now, let us have a look at doing star memory. So that's the PRMs there. Andrew says he'd like MemoryA uses it for poking hardware. Well, that's fair enough. We can add that in. I think, from what I remember, it's relatively simple. It's basically the similar interface to star MemoryI, or just star memory, and then you can enter hex or decimal values. Yeah, something like that anyway. But I'll have a look at it in a moment. So let's start out by showing people what we've actually got. So this is the module here. This is the sources here that we've got, and this has got a RISC OS directory that contains just the RISC OS specific things in it. And we've got a number of make files that contain the different parts of the build. So there's building the library, which is the DARM library, building an example, which is just the example code from the documentation, building the dis file. Now, dis file was a simple command that just did disassembly, and then there's making a module as well. And we can have a look in the C sources here. We can see that a lot of these are symlinks to the original source code. We've got the example code. So this is the example code that we wrote. Just does a very simple, this is a word that we want to disassemble, convert it to a string. End of story. Nothing particularly complicated. And then if we go back to the previous page, we've got in here the dis file code. So dis file is the one that disassembles a file. This is effectively *DumpI, and this does some of the conversions. It calls into a function here called disassemble word, which actually I moved into a separate library. So although this file is very short, it just contains a little bit of parsing, and then we call into the disassembly code here, which disassembles the file and prints out stuff. The bulk of the actual disassembly itself is done in RISC OS disassembly, and this provides the actual implementation. So we've got SWI lookups, and then we've got a little bit of veneer to that, and a tiny bit of cleanup to change the modern version of the SWI call into an SWI. And we also make sure that if we didn't get anything back, we report undefined instruction like the original. No comments in this, no disassembly comments in this. We could add those later, but for now, it's okay. It's not particularly impressive, but it does the job. And then we've got the veneer. So if we go back to the veneer here, this is the thing that actually does the module translation. So this was just using a stub that RISC OS project created. We've got some stuff that starts up and shuts down. We can get rid of that. And then we've got the disassemble word calls for both the disassemble call and the disassemble thumb. And we change those over to both of the forms. So not very exciting, but we do the job. So let's just do a quick demo of that module working. So pyrodev, what did we have? There we go, yes. So this is an example actually of we load the module and then we start up basic and we try to, I'm forgetting the words, we try to do some debugger operations. So let's give this a whirl and I can show you what it does when it starts up. Okay, that didn't work. I don't know why that didn't work, and I'd forgotten why that didn't work because I said I wasn't going to. Yeah, anyway. I was doing some work on it last night, which I will very quickly go and show. So if we switch back to projects, RISC OS, Pyromaniac. I forgot to change branches, so I'm currently doing some work on ARC64. And just to demonstrate the little bit that I've been doing, so I've got a if we do util /RISC OS DumpI test code in ARC64 hello world. So this is a hello world program, which if you try and disassemble it in ARM doesn't work. We want ARM64, please. Try that again. Better. So yeah, this is a program. It goes and stacks some registers, manipulates move the stack pointer around, sets up a pointer to this offset here, which is the hello world. Sets R10 to be number 2. Number 2 is the SWI number for OS write 0, and then calls the SWI. The SWIs are much more limited in ARC64. You've only got 16 bits of SWIs. So instead of passing the SWI number in the instruction, you pass it in using R10, which is equivalent to call a SWI R10, oddly enough. And then you can run this. So if you did pyro.py, I've forgotten how to do this, test code bin ARC hello world. And give it a moment or two, and it prints out hello world and then gives us an error. I did a little bit more work on that last night to fix that bug. Oops. Git set origin, set upstream. There we go, yeah. We execute a hello world. So that's a 64-bit executable running in RISC OS Pyromaniac and running SWIs. Obviously only one SWI call at the moment, but if you called any of the file SWIs and the like, it will probably just work. there's a huge amount that's not implemented. The error that you just saw, the interrupt1 not implemented, is an undefined instruction, so that breaks badly. But yeah, anyway, that's not what we're showing here. Let's get us back to master and clean away anything that's left behind. So, right, we're back in ARM32 world, and this loads the module and then starts basic up. Here we go, and you can see that the module has initialized, which is good. Sys debugger disassemble. I've forgotten the syntax already. Give me a moment. It's this SWI call here. Oh, which isn't actually a link. That's interesting. There's the SWI, I think. That's the one. Instruction to disassemble and the address to assume the instruction came from. Okay. So if we go back over here and then do instruction, I'm just going to lie. And the address it came from doesn't really matter. And the results turn up in R1. String. I think I typoed that. Is that? Yeah, there's only one S in the beginning part. Oops. We might as well do print string. There we go. That's an instruction. Whee! And you can also do thumb instructions as well. I have no idea if this is a valid thumb instruction at all. Apparently it is. So there we go. That's the basic debugger starting. Not really doing very much, but there we are. So what did I say we're going to do? We're going to do some disassembly with, not disassembly, dumping with star memory, and then probably MemoryI. MemoryI is already, oh, is MemoryI implemented? Did I implement MemoryI? I probably didn't. Let's have a quick look. No. Okay, so let's implement MemoryI first, because that's actually the simplest of them. And in order to do that, let me just take away the regular debugger and help MemoryI. I don't remember the syntax. So address plus or minus another address plus another address, an offset. Okay. And there's also the option to use thumb instructions, ARM instructions, or ARC6 instructions. At least on this version. I don't think the standard version of disassembler has that, but we'll be able to do it here eventually. We'll certainly be able to do ARM and thumb. Okay. Oh, also star MemoryI 8000. What does it look like? Okay, so we've got address, text string, and then some words. So this is actually very similar to what we had in the disassembly code. So probably it's exactly the same sort of thing I want to do. Okay, let's start pinching some code then. Quit out of that and have a look over here. So if we have a look in Veneer, here we've got, let's make this a bit bigger, shall we? There we go. Right, so we've got Veneer here. This has got a init command and a finalization command, not command, entry point, and a disassemble and disassemble thumb. We also want some commands in here, so let's go and define some commands in the CMHG file. Where do they go? Generate veneers, vector tables, commands. All right. Oh gosh, I remember doing these. These are kind of fun. Right, so the command table is one of the more complex. The first entry is the routine to call to process the commands as they arrive. The remainder of the entries are the command definitions. These take the form module command. All right, so this would be here, MemoryI, MemoryI, min args. Right, let's have a look back. So the minimum number of arguments it can have is 2 arguments, I think. Yeah, that looks right. And the maximum 1, 2, 3, 4, 5, 6, I think. So min args down here is 2, max args, I think I said 6. It's not a command. Add syntax. Yeah, we'll add syntax as well. Let's make this bigger. This would usually be a bit simpler for me because I'd be just seen Celia saying, first define fun. Yeah, I have a different degree of fun to other people, I think. Right, invalid syntax. Oh, you know what I'm going to do? I'm actually just going to copy the message that we had. Oops, I've gone too far in the help string, just because I can. Invalid syntax should print out all that, please. Copy, quote, paste, quote. And I might as well take this string as well. I'm not going to do color on this implementation, so that's going to be fine. Help is that looks like a sentence. That's good enough for now. We don't need it to do very much. Oh, and it's called help. It helped text, so it helped you read the instructions. Text. Right, and then we can also provide a handler function. And actually, I'm going to use it with a handler function just because it actually makes implementing these things a lot easier. So this is going to be command MemoryI. All right. So there we are. We've got a very simple command. So now, if we build this, oops, RISC OS ammo, make a module, and we should fail because the commands aren't defined, which is okay because we're going to go and look them up. What we should have done here is we should have provided a header file, which I think we have somewhere. Yeah, that's built the header file there. So if I have a look in the header directory down here, I should find there is a modhead file which contains the new functions I need to implement, along with all this. There we go. Copy that lot and drop it into the veneer. Drop it here. There we go. Right. So mod command isn't actually going to do anything. As far as I remember, there's no way to disable mod command if the actual entry point, if you've already defined them for each individual SWI call, command call. So we just have to make that one empty. In order to remind me what's going on here, I'm going to drop back to here and copy the syntax. Oh, hang on, the syntax is wrong. I'm not implementing v6 at the moment. Not v6, sorry, I'm thinking IP. ARC6, 64, sorry. Frame, no good. Right, so that's what we're implementing. So the way we want to do this is to call os readargs. Do we want to call os readargs? I'm not sure. So osReadargs lets us provide a argument specifier string and then decode it, but the syntax is actually a little bit strange because plus minus could appear, that could actually be like that. It could be appearing right beside it. And of course the registers aren't going to be they're not going to be parameters. So probably it looks like we may actually need to just pass the string manually. That's fine, we can do that. So parameters we're going to need is whether it's thumb or not. We're going to need to know what the address is. So we've got uint32s here. We've used the base address, uint32t, the end address, I suppose, is the one we want, and then we could also have an offset as well. And we'll have a flag to indicate whether things are negative as well. You know what? I think I'm going to look at how I've implemented it inside Pyromaniac and see how I've done it there, because almost certainly I've implemented it in a quite structured way there, and whilst I could work something out here, it'll be a lot faster for me to have a quick look at that. So, just happens I've got a window on Pyromaniac here. So let's launch an editor on RISC OS modules. Is it core module? Hang on. Oh, it's not modules, it's Py modules. Sorry. PyMods core. Debugger. There we go. Debugger. Probably the init file, please. Okay. Oh, it's turned up in this window. That's handy. Right. So if I look at command MemoryI. No, I'll imagine I use the same syntax. Command MemoryI. There we go. This is the input. Ah, yes. Okay. So I've got two sets of functions. A parse architecture to disassemble, which pulls out the first bit and decides what architecture to use, and that's this function here. And then another one that pulls out the memory parameters so that we know what those parameters should be. Okay. I think it's probably a good idea to try doing the same thing. I mean, that looks nice and structured, so I think maybe that's the way to do it. Yeah, got a disassemble and some arguments, so we actually return two values. That'll have to come back as a structure pointer or something. And this again, we've got the base address and the other address. Yeah, another structure. Okay, that's not too terrible. What I'll do is I will copy the parameters here and then go back to where we were, and we can implement it here in the same way. So, that's not right. Struct parsed arg. Oh, I'll just call it parsed arg. I have to do a type def. Type def. I have to remember how to write C code now. So enum maybe do it as a yeah, I'll make that a type def as well, just because it will make it easier for me if I need to reuse it. Interesting. And arc arm32 arc from. That'll do. Arc T. So, and then what else do we need? We needed to know the disassemble. What's disassemble? Oh, that's interesting. What is that? Oh, that points to a disassembler. Oh, points to a disassembler. We can actually have a function pointer there, couldn't we then? So we could actually have... I'll have a think about that one as we go. I've got an idea about how we do that, but I don't want to overcomplicate things by trying to work out everything in one go, because I will get myself very confused. Right, this is the part. So this is the memory parameters. So memory params, structure, params. Okay, so the reason I'm putting these into structures is because unlike Python, we can't return tuples of many values. So we can pass in a structure and then it gets populated and then return it back. And then that will give me the right values that I want to use. So we've got a number of things that we're getting back here, which is unsigned int 32. Hang on. It's actually these parameters here, I think. Oh, we don't actually have an offset. That's fine. Yeah, we don't have an offset because that's actually handled elsewhere. In fact, all of those will be handled elsewhere. Okay. So I see, this is how we're going to call it. Parse architecture from the arg string. And we want to write it into memory params. Oh, and we get back a new arg string saying where we got up to. Memory params here. Oop, no, memory params T. Memory params. Okay. No, that's rubbish. I'm doing this wrong because that's not the memory parameters, that's the architecture. Parsed architecture, T. Parsed arch. Next. Try this a second time. Architecture is really living up to my a really good engineer doing things, like can't even write my functions properly. Yeah, it's no big deal. And parse memory params. Okay. Bum bum bum. Oh, interestingly, we pass in a size in instruction width. I'll come back to that one because that only matters if you're into decoding thumb. Yeah, it's fine. Not going to worry. No, I am going to worry. Default size. So default size is the number of the amount of instructions that we want to decode it if you don't specify anything. So I'm going to put that as 16, I think. MemoryI default size. Make that 16. Instructions to disassemble if not supplied. Bum, bum, bum. And then we pass that in here. Ah, you see the disassembler also gets back the instruction width. So I'm going to have to add that into here. Int instruction width. I'll use the same variable names, then at least I don't get myself too confused. Inst width max. And I think there's also an inst width min as well. I'm pretty sure we've got one of those in there. So inst width. And we can pull that out here. Inst width equals past arc dot inst. Come on. That code looks very, very similar to the other one. Oh yes, except we've got to pass in the maximum size. So I forgot what I'm doing. MemoryI. Oh, I typoed that. MemoryI. Oh, default size times inst width. So the reason that we need to know the instruction width is because with the instruction width, we can then go, I want to get 16 instructions, whether they're 2 byte long for thumb or 4 byte longs for ARM. Okay. There are still some bits missing here, like most of the code, but that's fine. Yeah. Now we need to start implementing some bits of it. So, parse architecture. Well, that's going to be pretty simple. It returns a const char star parse architecture, takes in a const char star args, and it also takes in a parsed arc t. We'll call that parsed arc. Okay. Now, one interesting thing about this is I can't do it exactly the same way. So I'm going to have a look at, if I just jump back to the function here, the one that was actually implemented in Python. So we switch back to the Python code, and you'll see here that we've got a bunch of bits here that try and interpret it and then return the values. We're actually doing an uppercase thing here. We can do that, and then we just cut off the string. So we're actually manipulating the string in the Python, but in the code we're doing here, it will be coming out. Okay. I've just seen an error. YouTube is not receiving enough video to maintain smooth streaming. Give me a moment. As such, viewers will experience buffering. Okay. Are you guys seeing buffering at all? Is this something I should twiddle? Is there something I can twiddle? I mean, I've got only so much upstream. Maybe I need... Oh, I'm not sure. No buffering here, says Alan. Okay, is it? I mean, as long as it's looking smooth and doing okay. I mean, it might just be YouTube is concerned rather than you guys. We'll see. Okay, let's go back to looking at things here. So, right, we've got this function. It does some stuff. In order to be very lazy, I'm going to copy the lot and then I'll implement what it does, as I said. So this is not going to be very difficult. I mean, we're not actually doing very much that's complicated here. So first thing we're doing is we're doing left strip, which means skip any... All smooth with no stutters, says Alan. Cool. Yeah, fine. I'm not going to worry. Cool. I'm still learning about this and how the streaming process works. And obviously I'm only seeing one side of it. Talia's watching some more of it as well, so she'll be able to like give me a rundown on any bits that went wrong as well. So if you do have any feedback, then feel free to either drop things into the chat or just, I don't know, drop me an email or something afterwards. You know where I am. So that's pretty easy to do. We've got 6 viewers. Woo! It's quite cool. So lstrip was what I was up to. Lstrip will cut off the spaces from the beginning. So we'll just try and do that while the first character is a space. Skip over it. Then make it an uppercase. In which case we're going to need a character C. C equals star args. Actually, it would be to upper star args. If C, oh, I've actually called it. Why don't I use the same variable names? Come on. If I use the same variable names, then it'll be more obvious, and I'll be able to compare things and see where I've gone wrong and stuff like that. If it's a T, nope, that's not C syntax. In fact, that's not C syntax at all. I can use the same variable names, but I can't use the same language syntax. Right. So if it is, then parsed arc dot arc equals arc bomb. And we know that parsed dot, is it min, instruction min, there we go, equals 2. And we know that max is also 2. So the reason that the disassembler structure in the Python version has a min and a max is because some instruction architectures don't have fixed instruction lengths. Obviously ARM has fixed 32-bit, but Thumb actually has a minimum of 2 and a maximum of 4. We're not actually going to be decoding the 4-byte instructions at the moment, so we're going to ignore that for now. But it's possible. And of course, for example, 6502 has a minimum of 1 and a maximum of 3. And x64 has a minimum of 1 and a maximum of, oh dear God, how many can you count to? There's a lot in x64. So anyway, I'm not doing those just yet. Anyway, so else, actually, this is not an if, it's a switch statement, isn't it? Yeah, there we go. If I use the right language, I can actually like have a lot more sensible structure there. Yeah, we go. Python doesn't have a switch statement, which is frustrating at times, and it means that you end up having to do if-elif structures like down there, which is quite tedious. Right, so this is ARM32.4.4, and I'm not implementing the 6 at the moment. So if it understood the character, then we need to step over it. But if it didn't understand it, we just continue. Default, don't need to do anything. Actually, no, default, sorry, I'm lying. The default is we switch to ARM. The default is we switch to ARM. So if I do that, and then only if first is A, do we do the increment, that'll have the same effect. Okay. Doop, doop, doop. Oh, that's interesting. Ah, right, yes. So we only pass the next letter if we've got a string and the next character is a space or the end of the string. And the reason for that is you could have done star memory AOO to disassemble from address AOO, and we don't want that to be interpreted as an ARM thing. So let us very quickly tweak this. So if oops. So if the first character is a real character, it's not a control character, any of the commands that come in through here could be control terminated. The implementation inside RISC OS Pyromaniac is that it's always 0 terminated, your command string, but it could be control terminated in classic RISC OS. So we have to be a bit more careful there. If there is a character and the next character is a space, or the next character is a control character, Yep. There we go. Then that. Otherwise, first equals nothing. So that won't match. It'll go into the default case. All right. That's what we've got down here. This is all the Python code. And we're returning we've updated the parsed architecture, and we're returning the string with args. There. Missing brace there. Okay, so that's going to parse the architecture. Let's quickly document that, if I remember how. Architect. Parse the string specified. Architecture. Parameters are args, points to the command string. Returns pointer to the next. String. What else? This one here is structure to fill in. Okay, some of those letters were right. Structure to fill in. That looks kind of right. Let's just spin down a bit. All right. Now we need to implement the second of these functions, which is parse memory parameters. Let's do that now, yeah. Parse mem const char star arg string params t pointer to that. And default size. We're certainly going to want those or something similar to those. Const char star. Right. And as I've just done the other one, I should probably do this one. Memory. That's interesting. My editor just triggered something. I didn't know what it did. Anyway, arg string to non-string controls terminated returns into the next character in the string. Yeah, I could probably have copied those. Yeah, I do find that I hit the wrong key sometimes and something happens and I'm like, what did I just type that did things? But I don't know what that means. Probably means that it seemed to be when I held down caps lock, a little caps lock locked key came up, which I've never seen before. Because normally if I just tap caps lock, it turns it on or off. But pressing and holding it seemed to do something different. Well, new and exciting features, or at least things that happened. I haven't yet found it's useful. I'm unable to type today. Structure to fill in. And finally, default size is number of bytes to use if no length is given. Oh, no length is given. So it's valid for you to do star MemoryI 8000, for example, which means that the number of minimum parameters is not 2. The number of minimum parameters is actually 1. There. Okay. Size is given. Okay, right. Just because I've written a bunch of stuff, I'm going to go and return null from there, and I'm going to make this print out some bits, and we can actually see what's going on. Arg string equals %s. Arg string. printf inst width %i, and the other one was architecture is %i. So let's print those out and parse arc.arc. There we go. And we know that that's not going to produce anything. All right, let's go build that. So, oh no, wrong window. This is Pyromaniac. Not going to do anything useful in that. Build this. Good. This is my old compiler biting me in the behind. Yeah, doesn't allow the commas on the end there. Some spacing in here, I think. Inserted semicolon or comma before typedef on line 91. Semicolon, semicolon, semicolon. Oh, but I missed a semicolon there. Okay. No characters in character constant at line 120. Yeah, that's right. Less than space. Inventing int to upper. Well, that's correct. Yes. I haven't included C type. And apparently I've been accessing these all wrong because I'm an idiot. I've been using Python for too long. Go to line 128. Yeah, all of these dots here should be arrows. So let's change all 3 of them at once, like that, and then move down to here and do the same with these ones. Okay. Right, we have a module. And since we have a module, we can run it. Load the module and then start basic. MemoryI 8000. arg string is 8000, instruction width is 4, architecture is 0, which was the ARM architecture. Now try it as thumb. Looks good. Feeling quite glad that that's actually worked. So at this point, we have an interesting situation where I'm writing code that's going into the module, which doesn't need to, because all I'm doing is doing some simple parsing of strings. This is all really quite rudimentary, actually. We don't need it to be in the module at all. So let's have a see if we can just lift all this lot out and put it into a file. Bum, bum, bum. All the parsing stuff here. I'm getting applause and claps all round here. It's wonderful. I've forgotten what I'm doing. Yeah, so I'm going to lift most of this code here and put it in a new file. So cut it out of here. What is this going to be? Do we call this parser? Yeah, let's call this parser. That's a good idea. So let's call this parser, I think, for a good idea. Instead of that, let's actually give things this assemble parser. How about CLI parser, because it's command line parser? Yeah, that looks much better. Oh, except we've used hyphens for most of our things rather than underscores. Let's do it that way then. There we go, CLI parser. So, there we go, we got those. So let's have a file header. This is CLI parser. Parsing command line arguments for the debugger commands. Date is, oh, I don't know, we're at the end of June in 2024, because, yeah, include studs int.h. That's a constant, the MemoryI value, so let's move that up higher in the file, just because, actually, yeah, that's a constant that's not actually used in this file. It's only used in here. So I can put that in here instead. Go back at the top of the veneer file. Go back to the CLI parser. Yeah, that looks okay. And of course, these structures are all going to be used in the other file. So we need to have a header that contains these. Let's create a new file called CLI parser in the H directory. And because we're lazy, we'll just what I shall do is I'll copy the entire file into the header file, and then I'll cut out the implementation. So I'm a little bit different to how a lot of open source and, well, even commercial software is. And maybe this is because I think we did it at Pixel as well. We have all the function definitions that include the comments up there like that are exactly the same in the header file as in the source file. Now that means that you've actually got the same documentation in two places, which is a bit frustrating because it means if you change it, you've got to update it twice. But you had to update it twice to change the parameters anyway. So I don't think it's a bad thing. I think it's quite a useful thing. It also means that when you're reading the header to say, how do I use it, you should never need to actually look at the implementation of the file. So this is CLI parser H. This is just the guards to make sure we don't include the file twice and get errors from that. And I've already got the end if on that. And with that in place, I no longer need, well, any of this really. All of these definitions are now gone. So that's just hash include CLI parser.h. I also need ctype because we're doing the two upper in here. Okay, so that's CLI parser and the header file. We go back to the veneer now. We can go and include that. CLI parser. Okay. And I think that should just work. Except it won't, will it? Because I haven't updated the make file. So if I do it now, oh, that's the wrong command. Stop. Thank you, sorry. Try again. Make command, there we go. Yeah, it doesn't exist anymore. So now we need to go and edit the make file to add those in. Make file for the module. And we just add in o.dis. No, CLI. And then it should build. Or not. Oh, null. Yeah, null because that's in studlib, I think. Just give me a second to put that in. Studlib.h. Oops, .h even. Back over here. Build. Right, and we should be able to see that it works exactly the same as before. Right, we're still working. That's good. Oh. Okay. Right, yes. So that was that. We've now got a function that does some parsing. I think I'm at a good point where I've got something written that isn't useful, but is a reasonable checkpoint. So I'm going to go and check this in. So check out a new branch. This is going to be, we're adding in MemoryI support. Add MemoryI command. Oops, command. I'm putting it on a branch because what's on master at the moment works, and I don't want to be messing with master whilst it is working. I can now do everything I like on the new branch and it'll keep working. So let's have a quick look at what we've got. We have the module, the make file for module, the veneer, and oh, there's a file's missing. So yeah, I need to add in c/cli parser, oops, git add c/cli parser and h CLI parser. You know what I'm going to do? Just as a demo, because I'm like that. Okay. Star git status. Okay. Git status shows us what we're doing. Git, oops, star git add c dot, because I'm in RISC OS, CLI parser and h dot CLI parser. Oh, tab completion works in Pyromaniac as well, so that's quite nice. So if I do star git status now, we can see that that's showing me the right things, and we should be able to do git star git commit. This is where we find it doesn't work. No, it goes into the commit message editing. So, initial implementation of the parser for star MemoryI. Now include a star MemoryI command that doesn't work, but does start to process its arguments. Only the architecture is processed as yet. The memory handling will come next. commit star git push. Okay. Star git push set upstream. Is that implemented? Oh, I can do this. This is fine. His name is Gerph. Password. Hang on a second. Oh, what? Oh dear, no, that's not right. What did I just do there? Oh dear, that did not go well. That might mean I've broken it. I don't know how I inserted a code 0 there. That's rather weird. What is my Git password? GitHub. Copy password. Paste and hope that it doesn't paste it for everybody. Oh, excellent. Support for password authentication was removed. I knew that. Copy password. Different password this time. No, there's no LastPass shortcut. Create me a password manager interface as a module and I will make it all interface nicely. Try again. Gerph. Password. That one. Muhahaha. Right, okay. That has now pushed it from inside RISC OS. Hey! Yeah, I'm just showing off, I'm sorry. So, consequently, if we go over to here and have a look in the C directory, we should see a... Oh, of course, I'm on master, so I don't see anything. View all branches. My branch, add memory command. So we can now see they had some recent pushes and it's here. So if you're wanting to follow along and actually see it in your editors and stuff like that, you can. If you need to see it, it is, oh, here's the URL, copy the URL, copy, paste, delete the random garbage that it's got on the end. There you go, that's where you'll find it. Okay, so we've now got that. Cool. Next bit is then to start implementing the memory parser, memory arguments parser. Parameters, and that's a parameters. Yeah, try and get the vaguely sensible words. Right, and relax. Parameters. I want, if I have a look at the Python code and I scroll back up here. Oh, all right, let's go. Sorry, I've lost where I am. Memory parameters, this one here. Go to definition. Okay, so this is the memory parameters function, and it has a whole load of bits in it. This is the argument string, the size used if nothing supplied, and then a syntax message apparently, which, right, this is because we also provide a return for parameter for error values. That's interesting. I'm not going to worry about errors right now. I'm just going to make it return null if we have an error. I think that's probably a reasonable plan, just for now. We call another param, a function called param here, which does more processing to get out a string. Ooh, that's interesting. So how I'm parsing the string here is to use a regular expression to parse it out. I shouldn't be doing that. I should be calling, oh, Yeah, I should be calling read unsigned. They may wish to refer to a registering exception. For example, a register might be called A. Yeah, so this is allowing for the fact that in the future I may want to implement a different instruction set, such as, let's say, 6502. And then you could have an instruction called A, an instruction called X, and an instruction called Y, a register, sorry, called A, X, and Y. I might want to do that. That's the reason for that. So we do a little bit of more clever parsing. Oh yeah, and oh gosh. Right, this is more clever as well. So find architecture register will look at what the register name is using the definition of what the registers are. For now, we're going to completely ignore all of that and just handle it as a dumb parser, just because, well, we're being dumb. We're only starting out. Let's get this done in a sensible way. But this does look like a pretty reasonable parser that we can use. So let's go back into here. Even if we're not quite doing it the same way, we can still use the same principle. So, yes, it's all indented differently, and we've got a... Oops, that was a bit far. Different language embedded in there. It's going to get confused, but we can work with it. So, value, relative, and args. Oh, this is... All right, we'll just have a quick one for this. Type def struct. This is just local. Param-s. If you were doing this in assembler, you'd be actually returning it in 3 registers, so you could like handle it a lot more easily. But I'm writing it in C, so I have a little bit more fun and trying to do things differently. So what are we returning? We're returning a tuple of uint32. Oops, that's not typed there. uint32t value uint unint. I keep typing that. 32 uint32 relative position. Is that signed? Yes, it is. So it isn't a uint32, it's just an int. Let's just do it as an relative. And the new args. Ah, new args is char star args. That's the... Oh, so we could actually return an error with that as well. No, let's do that one. Ah, we're returning none for all of them. Okay, that's fair enough. Okay. Sorry if I'm not explaining myself well here. I'm reading through my own code and I'm trying to work out how to convert it in a sane way and realizing it's not actually as easy as I thought. But it's not a problem. All of these things are surmountable. So we've got unchar star args, which is the argument string we're parsing, and then we've got the param underscore t star, the parameters we're going to fill in. So first thing we're going to do is we skip any spaces at the beginning. So while star args space args. Cool. Then we've got params to relative 0. Actually, whilst I'm here, let me populate the definition. It's a param. This is read read a parameter from the argument string. I'm not sure that saved me any time. Oh well. Args points to the argument string. Params points to the block to fill in. Oop, I forgot to press return. There we go. Returns pointer to the So we've now handled everything up to here. If the character we're on is a control character, we've got an error. So we'll return null. Okay. If the character is a plus, or the character is a minus, params to relative equals, oh, this needs to go in places. Start args plus 1 or minus 1. Args equals args plus plus. There we go. And there can also be, I don't think this handles the idea of there being space between the plus and the next parameter. That's interesting. Maybe there isn't allowed to be a space between them. I'll just use the same implementation, I think, and we'll try and keep going. So I'm going to skip out that bit and we're going to go straight into doing the read unsigned part, because I think that's a good idea. So read unsigned, we do os read unsigned. I'm not sure how that works. Let me have a quick look at I don't have that command linked. I have a command line version of RISC OS PRM, which launches it into a little browser in the window, but it's not linked at the moment. No, I'll just have to go over here and have a look. Where's search gone to? I've lost search. No, that's not search. Search there. Os read unsigned. Ooh, can't type. Read unsigned. I think that's the one. That looks like it. All right. So let's go back over here. Os read unsigned. Base is 16. I don't want any restrictions on it. So I'm looking at this. Base is 16. I don't want any restrictions on it. I don't want any restricting the range to there. And check the control character, I don't want that. So it's literally just 16 is the only parameter I'm passing in. Pointed as a string, and we're not using the maximum value. So in fact, what I'm going to do is I'm going to make this a helper function called read hex, which will call into read unsigned from args into args, and What do I return? Oh, the value, yes. Params to value. So now we need to implement os read unsigned. So uint 32t read hex, which takes in a const char star. So you might at this point be thinking, why am I not calling scanf or something similar? Stray u to int or whatever the thing is. Yes, stray u to int. Strut int. Or whatever it's called, I don't know. Strut I. And the reason for that is because if I can do it this way without actually using any of the standard library functions, what I've got here should be able to be used much more simply. Now, of course, the main library will be using the DARM library will be using a lot of the shared library as well, shared C library. But it'll only use certain ones of them. So we might be able to get away with some more a simpler version. And why might that matter? Well, if I want to pull this code into the actual assembler debugger module, I won't have to implement parts of the C library. I'm not sure that this is a good argument as I'm giving it even now. So yeah, feel free to diss my my argument there. Anyway, this is what I'm doing. So yeah. It'll also mean that I'll be able to use things elsewhere. I don't happen to have a function like this lying around. So hang on, read unsigned, and the pointer to the string args, comma, ampersand value. So that comes out there. And then, actually no, I might as well keep it doing the same thing, right? And say args in there, and return the value there. Yeah, that looks reasonable as an API. In fact, that looks so much like a sensible API that I might actually just want to do a return there. It may look to you like that function is kind of pointless. Not sure I'd disagree if you thought that. Ooh. I've just had a thought. I'll leave it for later, but I'm going to make myself a note because this is a interesting idea for a project, probably in a couple of weeks' time. No, probably a couple of months' time, actually, come to think of it. But I'll tell people about it later if they're interested, or when we're on another chat. Oh, yeah, args. Const star args and const. Oops. Const char star args. Scripts. Oops. Read unsigned. Input arguments are registers 0 to 1, and output arguments are. I think we're only returning the pointer to the. Oh no, two arguments. The term the endpoint and the value. There we go. So that is base and flags in R0. Let's reformat this, it'll look a bit better. We are all up to 8 people watching now. This is shocking. I think we got up to 9 last time. Yes, last week, but a couple of weeks ago, which is quite nice. Okay, the output parameters are args and % value. There we go. Int 32t value, and it's kind of loss error, isn't it? I think that's what it is. Ooh, that's not the right key. What did I just do? Huh. Apologies, people. I've apparently when I've got LastPass loaded, one of my key sequences in my editor doesn't work properly. That was not what I wanted to do. If I press Shift, so one of the things I did earlier that you might have noticed was this. So you end up with a long cursor and you can type things. I believe StrongEd has something similar. But there's another way you can do it where you can select all the section and then do Shift Command L, and I get all those lines get a cursor on them, so I can do things on it. And the idea is that you can do like mass editing of things. That wasn't very useful, but trying to do stuff like that makes things edit easier. I think I used it last time on the when I was editing some of the Python code, but it's a very useful thing to be able to do mass edits. If we have an editor, args equals null. Oh, hang on, I've got 2 variables called args. Args_p. Args_p being the pointer to args. That's what we're going to return is null, and we'll return the value. So we now have a function that calls us read unsigned, and a function that does reading x. Put these up here. I mean, I realise that people will be using different editors. Oh dear! I accidentally didn't delete the cut the thing I meant to. There we go, there's functions. So we've got a read hex there, relative positions, we've already done that. And I've said I'm not doing my fancy work that I've got here for register naming and things. Oh, except I do want to do it, don't I? I do want to do register naming. Oh, because you want to be able to say yeah, all right, let me let me have a quick think on that. So let me write a note. We want to be able to handle the register numbers here. So, for example, using R1 will give R1 from the current exception bank block. Oh no, you can't call it register, reg no, there we go. I'm not going to make it do anything properly here, but I'm going to at least write the stub for this. So if regno equals parse register with the arguments and the args to update. Ooh, regno. If regno, I'll have a cup of tea, yes. It's great having cups of tea made for you. Thank you very much.
Yeah, you did great.
See, tea. All good. If regno equals -1, I'm just going to say -1 is invalid and everything else is okay. Then we read the hex value. Else rams to value equals fetch register regno. Then we can return logs. Okay, now I need to implement 2 more functions. Oh, hang on. Yeah, there we go. 2 more functions. Parse register. Can't spell. Well, we knew I couldn't spell anyway. Fingers. Okay, const char star. Oh no, not const char star, sorry. Int regno. I must admit, it's very strange not to be able to see people when we're doing this. I've got quite used to doing to chatting to people and having lots of windows of people being seen, and it's like a little weirder doing this. I mean, it's not wrong. It's just I've got an audience that is, well, may not even be there, and it is just watching and leaving chatty things every now and then. I should be a star XP. And people are being nice and making coffees for one another, even if they are in different counties. Yes, counties, not countries. 10 people watching now. Woo! We have to keep it up, don't we? Right, so return -1. There we go. Yeah, we should actually note that. Fix me. Implement this. Should use the CPU arc registers description. Right. And fetch register. I think I called it fetch register, didn't I? Yeah, fetch register. Which returns read a register value from the exception block. Oh, maybe we scared somebody off. Oh, I imagine it's that the additional people are people switching to their phones whilst they go and make coffees. I don't know if that's true, but it could be. Yeah, what I'm doing. I'm going to move a bit over here. Actually, I might be moving out of shot if I do that. Am I moving out of shot? I'm just watching myself. No, I'm in shot still, I'm okay. Not great because of the window beside me. It's so very bright outside today, which is nice, but it's not as hot as it was previously, which I'm also very appreciative of. Right, parameters. Reg now. Oh, hang on, no, not you don't write it that way there. Oh, my brain's going to sleep. Register number. So, uint 32. Oh, this is interesting. So actually I shouldn't be using uint 32 because for the given architecture we're using, the value for a register could be much larger. So I should be using a special type that says what a register length parameter. However, for now, I will just leave it like that. Yeah, that's just... We're not dealing with registers that are 64-bit long yet. Actually, I wasn't specifically thinking of 64-bit long. I was thinking more of 8-bit long, because if you were implementing a 6502, you would have 8-bit long registers. Or 16-bit, because the PC is 16-bit. Int reg now 10 0. Right, so somebody's just said that they've joined and they didn't they didn't catch everything. And Dave's asked, what's my favourite burnt C type? A singed C char or a charred int? I feel very stupid because I haven't actually thought of that one before. Fine. Okay, so we are about an hour or so in, aren't we? What are we up to now? Yeah, hour and a half in. So what are we doing? Last time on Gerph's live coding, we had I created a debugger, which is here. Hopefully the history is there, and you'll be able to spin up to the history and see the link to the DARM repository on GitHub. I ported that library. It's a 32-bit ARM disassembler, and I am now in the process of adding the command MemoryI, and I'm doing it with reference to the Python implementation that I have in Pyromaniac. Why am I doing it with that implementation rather than looking at the assembler code? Because I don't want to look at assembler code. I don't ever want to see it if I don't need to. Detail on the screen is slightly hard to make out. Sorry, Vince, I can't do much about that. I've made it as big as I can to make it actually useful. You might be able to zoom in a little bit, I'm afraid, but I can only do so much. If I make it much bigger, I end up having text spanning the entire screen and being quite crippled. Then bump it up a little. Let's have a see. I mean, I'm on 17-point text at the moment in here. Let's do that and that. We're doing spinnies at the minute. It's thinking about stuff. I unfortunately have rather a lot of windows and tabs open, and Sublime Text tries to resize every single one of them. When I say rather a lot, it's probably in the order of about 1,000 tabs open or something stupid like that, so it does hurt a bit when I do that. It's having a think. All right, anyway, sorry, I was talking about where we were up to. So yeah, I was going to do adding some commands to the module to make it able to mirror more of the debugger module. And so at the moment we're in the middle of implementing the command line parser for star MemoryI because it's a little bit special. And I've maybe gone a little bit over the top, but meh, what the heck. So that's where we're up to. At the moment we're at the point of trying to parse the register numbers. I'm not doing those. we've got a function here that does parameter parsing that starts to handle the plus and minus bits of it. And we've got a basic function here that is what we're going to fill in with the implementation of the parser. Actually printing stuff out once we've got all this data is going to be a doddle, but for now that's where we're up to. All right. I was just about to explain. Yeah, I'm planning to do this probably once every couple of weeks. It might be every other week. It depends on how I'm feeling and how much I get through. Because I'd like to get through most of this module in just a month or so. I did like 4 hours previously, and this is my. Thank you very much. Wonderful. See, cups of tea brought to you. Wonderful service here.
Thank you very much.
Love you. What more could you ask for? Yeah, so I'm planning on getting most of the debugger module implemented in about a month, and I've done 4 hours already. I'm going to do well, whatever it comes to today, probably around about the same time, and we'll see how we get on. Nice. I've also got my pineapple juice here as well, so I will be able to drink that too. It is quite warm today as well. Not as warm as yesterday, as last week. And I've got myself distracted. I was talking about CPU arc registers. So I have alluded to, when I was doing the Python code, the fact that we've got find architecture registers, which looks up a given register name for a given register name for the current architecture, or we should really do it for the architecture you're looking at. And the register names might be different. If we look down in the, well, when we were looking at the debugger interface, there was also some stuff that did that as well. And this is because in some architectures we'll have different register names. In ARC64 there's registers named W, X, and I forget what the shorter one is. They're all the same registers. But there's also a bunch of other registers that we could implement if we were doing the floating point stuff as well. And if you were implementing 6502, you'd have them called A, X, Y, PC, and SP. And if you had X64, you'd have, oh my god, a big mess of them. And you'd need to look them up. So, in the implementation that I've got in Pyromaniac, there's a way of accessing that is more structured. So, I will show, as I believe this is now documented. Pyromaniac.riscos.online. I'm hoping this is going to be visible to people. If it's not, then please let me know. I'm thinking that's a bit small, so I'm going to bump the size up. Oops, I'm going to bump the size up a little bit. I think that's better. Ooh, that might be a little big. I don't know. Let's have a see. In the program environment documentation, there is a describe CPU registers platform features call. And this describes the CPU architecture layout and register layout as used in the table of registers in the register dump area. And this includes a bunch of things like different architecture identifiers, and these match up to the architecture identifiers that are used in modules. As you probably, people who've been watching will have remembered, there was a minimum and maximum instruction length. That's what they're for. And then there's a definition down here of what each register identifier is, what the flags are for it, and things like that, so you can actually determine programmatically what the registers are for. And of course things like register length, because in ARM all our registers are 32-bit, but for example in 6502 you've got 8-bit and 16-bit registers. The PC is 16-bit. SP is, well, it's 8-bit, but it's actually 8-bit with an offset, so you could consider it as 16-bit. Anyway, or 7-bit, sorry, 9 bits, I suppose. Anyway, that's what that is and why I'm referencing it. If you're interested in looking into that, please do have a look. It's not particularly complicated, but we will come across it later when I'm talking about other things. This is quite nicely documented. It's only supported on Pyromaniac at the moment. Anyway, I digress from what I was trying to implement. So I'm going to rename this to what it's called in the thing, which is describe CPU registers. Describe CPU registers. I think that's what it's called. Describe CPU registers, yes. All right, and as I say, I'm not implementing it here. Just let's leave that for now. We'll come back to it because it will become easier. Parse memory parameters. So we've got a function here called parm, which will do some more stuff, and we've got the parse memory parameters. And the reason that we have it is because when we looked at parse memory, where is it? It's this function here. Oh, it's just called memory param. Sorry, go to definition. Here, when we looked at this, we were calling that function. That's nice and fruity. Probably want to think about that in the future. Right. Having done that, let's copy that function and move back to here. And now we'll implement it. So these are actually not probably what we want, aren't they? Let's have a see. So we've got 3 sets of blocks here that get called into param. So let's have a look at these. Param. So we want something called base param. I've got 3 of them, sorry. One called base param, one called other param, that's just amazingly well named, and one called third param, I suppose. And those are all called parameters. So args equals param bracket arg. All right, we'll call it arg string here. No, I'll call it args because that's what I've called it in the function down here, and I can then match it up to the implementation in Python, and it'll be a bit easier for me. So args equals param args, comma, ampersand base param, and then repeat, and then repeat. This time other param, and then third param. These are amazingly well named, and of course we have to remember that some of these might return null. If they return null, if args, maybe we should initialize the parameters first. Params to I can't find the structure. Where's the structure gone? There it is. Value and relative. 0 and relative equals 0. So whatever we do, params is always going to be initialized. Okay. Spotted a typo. Right. Oh, and the point of that was that if args equals null, return null. Just die at that point. Okay. So I still haven't got a way of returning an error here, which is a bit of a pain in the behind. It shows how I've failed to think about this enough. What should we do? I think what I'm going to do is be lazy and just return null, and then we can just say it's invalid, and then we'll add in some error handling later, just because I want to be able to demonstrate things that are actually useful rather than and get something that's working rather than being perfectly accurate. So for now this will do. So if base brackets, sorry, base param dot relative return null. If third address is not none, so that's the value. If that's set, that means that we've got a 3-parameter form. Oh, hang on, base. Sorry, that's wrong, isn't it? That's not that. That should be third param. The third param value is none. Is not one. There. Third param dot relative is not one, or other relative. Vince just said I fully endorse laziness. Laziness is good. Also has to be accompanied by a bunch of awareness of why you're lazy. Sometimes it's because you just don't care and it doesn't matter. And sometimes it's because you're just trying to get something done and you don't care. Other times it's because you're just lazy. Yeah. So, if that failed, report a syntax error, which is a string. I was going to say, and that returns the general syntax error, which I haven't passed in here because it wasn't one of the things I thought about. This is not going to be quite as nice, but it's okay. Have I got that wrong? Have I? What have I done here? Oh, okay, I see what's going on now. Right, so that's in that. All this lot should be indented. Sorry, undented. Undented. Dedented. There we go, that's better. Base address. Base underscore region dot value. It was value, wasn't it? Yes, it's value. Equals base region value. I'm regretting my choice of variable names here. So I'm relying on the fact that multiplying by 0 or 1 will take me to the right, doing the right thing. Realistically, we should probably do, if you were being more careful, you might do it. If it's +1, do this. If it's -1, do the other way around, because that's what you do in assembler. But using a multiplication here is just fine. We don't really care at the minute. And we're not operating with floating point numbers anyway, so we're not going to lose any precision on this. Third region dot value. So I guess I'm also showing here how you convert bits of Python, random Python code, to be useful in C. Is not none. Other region dot value. So actually this is wrong. So these checks here should be checking, did we populate it, is what it's saying. And interestingly, what I did was I set relative to be 0 if it was not set. So I can use the same thing there. So if it's populated, it will be non-zero. Actually, that's also wrong. That's wrong, isn't it? No. It could be 0 if it's not relative. Oh, that's annoying. Oh. Well. Giving the third parameter as 0 is not going to make sense. Giving the second parameter as 0 is not going to make sense. So let's just put those as 0 there. That's fine. I'm sure somebody can come along and critique this later and point out mistakes that we've made, because that's the point of doing things open source and giving people the opportunity to contribute where we've screwed up. I mean, help us out, not just fix our bugs. If other region dot relative is not equal to 0. Really regretting my choice of structure names. I could have called this address rather than value, and it would have made more sense. But then I think actually I did it wrong in the Python, because it's not an address. It is just a value at this point. And it's only when we're actually populating these things that we get a relative, yes. And the one parameter form means plus, it says 256 there, but it's actually default size, which is what we've got here. Region.value. This may not be the best of things to be looking at because it's not very exciting. Right. This is a pretty reasonable fix me comment. If they're inverted, swap them. Is that something that the original debugger did? Oh, of course! Yeah, so this is in the instance of star MemoryI 8000 minus 20. So that'll display you 20 bytes up to 8000 because it'll generate you the negative 8000 minus 20 and then swap them around. And that allows you to do that, which is kind of cute. In fact, I didn't even leave a note to that effect. Like that. If base addresses get another address, then swap them. Yeah, you can't do that in unit 32_t value equals other region dot value. Yes, I know I could use the EOR trick to go and do this instead of assigning to another value. I've just written base address. I'm not worrying about it. Oh, I can't. Come on, brain. Value equals other region dot value. Yes, I've got those round the wrong way because I just corrected it. Base. There we go, we're now swapped. And then finally we return some parameters, which is in memory parameters. So let's populate that. I've already forgotten what it is. So let's find it in the header file. Oh, it's base addr and end addr. Is that all we return? Yeah, base addr and end addr. So memory and params to base equals base region dot value and memory params to, what was it called? It was end addr, wasn't it? End addr? Oh, they don't have underscores. Let's give them underscores because that's how I was writing them. And I think that makes a lot more sense. Equals other region dot value. And then we return args. Oh, this is interesting. This is very interesting because if any of these ends up not being passed, args will now be null and isn't invalid at that point. Nothing follows on from this string. Yeah, nothing follows on from this string, so we could actually just return an error pointer here. I'm going to change this to be 1 for success, 0 for failure. None of them do they? Oh, they do. MemoryI does. MemoryI takes 2 of these parameters and a third one. Bother. It's a lot easier in Python because I can return tuples and I can do other things and like raise exceptions. Maybe I should have written it in C++. Okay. I made the decision earlier that I was going to try and not handle errors any more intelligently than just we have an error. So let's just do that. So this is a failure, 0. And this is a success, 1. Oh, this is a failure, 0 as well. Okay. What we got down here? Okay. Right. Just checking whether anybody's told me I've missed something. No, I think that's okay. So with that change though, that means that this and this have all changed in the declaration. So I need to change it in this bit here. Oh, yeah, apparently I've got an else colon somewhere, says Dave. Thank you. Let me just go have a look back. Else colon. Oh dear. Yeah, well. Oh, and I missed a semicolon there as well. Oh, and loads of semicolons missed. Oh, compile will just have a field day at this. Semicolon, semicolon. Oh, there's a colon there as well. Blimey neck. Right, let's just put an extra line in there just to separate the error conditions. How are we looking? Yeah, it doesn't look too bad. Let's have a go at compiling it, see what it does. No, compile, please. RISC OS ammo. There we go. Yeah, apparently not very good. Oh, that's good. I mean, yeah. I've missed out kernel loss error, that's fine. We can include swise.h, which we'll need anyway. Missing brackets on base address. Oh dear. Thank you. So this should have caught all of my Oops, no, that's move the window. Don't move the window. Put it back again. It'll do. Okay, so this here is the. Oh, I've got a duplicate line. Back here, 73. This is an args p thing, isn't it? Yeah, args p. Yeah, let's do that. Oh, and that shouldn't be ampersand args p. It should be just args p. Oh, I'm going to have to compile it again because there's too many noises there. 139. Oops, come on, go to 139. Value equals fetch register. Implicit cast a pointer to int. Fetch register. What did fetch register return? Oh, an unsigned int star. Yeah, that's garbage. It's a register value. Stupid. Okay. Inventing base region. Other. Did I not even call them that? Base param. Oh, right. Let's just do a search and replace on that because I clearly screwed it up. Base region should be base param. Replace all. Other region should be other param. Replace all. And third region should be third param. Okay. Ooh, that's much better. 190. Oh, yeah, right. Base region dot value and other region dot value. Oh, they're not called region anymore. They're called param. Just change them. So some of the more modern editors will allow you to do refactorings that will just allow you to change variables and they change everywhere. You just edit them in place. I'm not that familiar with those sorts of things and how to work like that, so I don't do it very often. I believe that I can get Sublime Text to do that with the language LSP stuff, but I haven't spent the time. Okay. Stuff compiles. That doesn't mean that it's going to work. It doesn't mean anything much. But at this point, it is now just over 2 hours. So I'm going to have a short break because it is a really good idea to have a wander around every couple of hours. Well, I try to do it every hour. And just have a little bit of a break, 5 minutes or so, and I will come back. All right, people. See you in a mo. Well, yeah, about 5 minutes or so. All right, bye. I think you've still got my sound so you can hear me, but I'm going for a wander. Right here. I'll see you in a second. Hello, peoplings. We're back. Had a bit of a wander, bit of a chat to Talia and stretch back and things. And we come into part 2. Sorry to see Vince has left, but he was having difficulty on that display, so no big deal. Okay, I'm just catching up on the chat and things. Right, so what were we doing? I've now built a module that has bits of the debugger in, and we can, in theory, run that. I mean, this is almost certainly going to crash. I will almost certainly have got something wrong. But let's have a see what happens. Okay, so I've got all that lot in the history. Huh! It didn't crash. Well, that's good. Let's just print out what the parameters were, and if these work, then we'll go and get this, what do we call it, committed. Because then we'll be able to, like, we've got another good checkpoint. So base address equals %08x. Memory params dot base address. Oh dear. Try and get my fingers right. And end address. Okay. Probably also want to check whether it was null to know whether we've got a bad pass or whatever. Oh, actually, yeah. Yeah, that's not going to work. I didn't compile it. Just for now, we'll return null there and do a printf. We failed. We'll fix that later, but this will just do for now. Build. Actual type long mismatches. Oh, I should have done LX there, sorry. And let's actually make it look tidier for RISC OS, just for the heck of it. Variable thumb declared but not used. Actually, I don't need that because it's already in the parsed architecture. Oh, I didn't save the file. Do it again, then we'll go and run it. Let's see. That works. 8,000 to 9,000? I'm really pleased with that. That's working. If we also do, I want you to do it as thumb. Yes. And if I do the 8,000, it should give me the default size. It doubles up. That looks good to me. Yeah, this is looking nice. So, I'm not going to do the git commits inside RISC OS again. I don't think I need to do that again. Right, what have we done? So at the moment we've added, completed the command line parser. Complete the command line parser. It took us 2 hours and I've only just completed a command line parser. Oh well. Parser now works and gives us appropriate. Oh, good. Yeah, that'll do. Appropriate parsing for. Okay. Right. Next thing. Very chewy sweets, these. Thinking. Yeah. Right, so the best way to progress now is to stop working on the module. Because if it goes wrong inside the module, for me it doesn't matter because it's Pyromaniac, it'll give me a whole bunch of data. But if anybody else were to be doing this, they would find that the crashes that they get and the problems that it causes make it very difficult for them to diagnose. So rather than working on the module, I'm going to move it into a basic, not basic program, a simple program. And we can use that for testing. So let's do that. So we've already got this thing called dis file here, which will disassemble a file. And it takes a bunch of parameters. It takes thumb and these. Now, since this is actually doing the same job as what we want to do, we may as well dump this in here, something like this in here. So we can do star MemoryI in the same way. So just so that people who haven't seen it, oh hang on, I've not pushed that. Sorry, I've now pushed it, so you can you'll be able to see it in the GitHub repository. There we go. Written 2 minutes ago. So, yeah, I was just trying to show this off. Sorry, show off this thing. PyroDev, common things, DOS. So, in here we've got a whole bunch of programs, and if you look in the AF32 directory, there we go, sorry, forgetting how things work. Dis file. So dis file is the command line tool that we wrote, and we can give it a file we want to disassemble, such as Debugger. I think Debugger was my my example file. There we go. And it's now disassembling it and printing stuff out. Yeah, it's a little bit slow, but meh. That's partly the debugger doing its thing. So it all looks pretty good, that, actually. I'm quite pleased with that. So having done that, we can now build the parser into this file and make sure that it actually does the thing we want it to do. So let's do that here. Alright, so first thing we need to do is include the header file to say that we want to use it. So hash include, what's it called? It was called, oh, I've forgotten already. Can't see it. CLI parser. This is really awkward for doing it with a file. Oh, that's supposed to be use it as a seek option. Yeah, we can use it as a seek option. So we can have bracket address, bracket plus or minus address. Ooh, I've got a slash in there. That's not what I wanted. I mean, this is something like what the syntax will be. And I'm going to make it if it's less than 2, it does that, because we've now got or argc is greater than 1, 2, 3, 4. Oh, hang on, no, 2, 3, 4, 5. Greater than 5. Okay. And now we want the parameters here will all have been passed in different argv values, so I'm going to need to construct a big string from them. That's a little bit of a pain, but we can do it. So let's just construct a big string. Construct a big string from the following arguments. I wonder if I should just increment argv there. Argv is equals to argv. So now argv points to the pointer, so if I do static char. Yeah, it's a bit naff, but we'll just do it. So while we've got a string in our list. Oh, actually, the argv list isn't terminated by a 0, is it? It's not guaranteed to be terminated by a null. So argc minus equals 2. Argc minus 2. Whilst we have arguments, the string is star star, let's start argv. Argv minus plus plus. Extra cat, command line. Oh, that needs to be set to empty string. I mean, it doesn't need to because it will be static initialized, but it's clearer. struct command line str, and then struct cat line, comma, space. There we go, now we've got a very long string, which we can parse. And to parse it, we need to have some code that looks surprisingly similar to this code, like identical. So copy all that, dump it in there. Pass parameters to the string. That's not very good. Pass the parameters into addresses. That's better. Failed. We can do exit 1 there. And then at the end, we have 2 addresses. So what I want to do is to pass in a uint 32 start equals 0, and uint 32t end equals 8 f's. And then we can go start equals memory params dot, is it base addra? I think that's right. And the other one is end addra. And we haven't actually got a default size here, but I'm going to go and set this just to a massive number, just because the default should be to dump the entire file. So I'm going to set it to, come on, don't stop going backwards, gone too far. Computer's a little bit laggy when I'm doing this. 1, 2, 3, 4, 5, 6. That should be big enough. And then we can pass those into disassemble file. Start, comma, end. Uint 32t uint 32b. Okay. So now we're going to want to seek in the file. So address, if start is less than address. So if you ask to debug from 6000 in a AIF file, an absolute file, what would that mean? That would mean don't do it, I guess. Actually, we'll just do an error. Error, cannot read, cannot, actually no, come to think of it. If you specified 8000, sorry, 8000 was the base address, and you wanted to disassemble a little bit earlier, 8000 minus 20, so if, this is what I'm trying to think about. So if you did, no, not MemoryI, sorry, DumpI, my absolute, and you gave the parameter of 8000 minus 20 plus 80. So that would be 7f EO to 8060. So you'd really want it just to dump from 8000 to 8060. So if start is less than address, I want to know the difference. So the difference between the two is start minus address. Oh no, I need to assign it to something. 8,000 minus, no, 7F0 minus that. So that's how far before it we are. Actually, if start is less than address, then we want to start at the beginning. We just want to start at address and end. Start equals address. Yes, we just start at there. If end is less than address, is before the beginning, we want to just give up. Do I have an end point? Ooh, I never closed the file. That's naughty. Oh, I don't think we returned anything. I don't need to do the F close twice now. There we go. Okay, that makes more sense. Now, if start is not equal to address, we need to do a seek. fseek. I never remember what the blooming parameters are. Man, fseek. Stream offset whence. Stream offset is address start minus address. Whence is seek set. And we are now at address start. Bum bum bum. And we also want to stop, and address is less than end. Oops. So what do you reckon? Do we think this is going to work? I'm feeling reasonably confident about this. Yeah, I feel reasonably confident that that's going to work. Okay, let's give that a whirl. Build it, please. Where's build it? Oh, I don't want to build that. I want to build the dis file program. Make dis file as a build 32, please. Yeah, that's not great. Yeah, that's stupid. So this is the command line here. Let's just put it. Oh, I'll just make them nested within one another. Really could do with a better compiler, but I don't have the time and energy to go and update the compiler I've got to that level. And you need to change the variable names. Let's do that as well. Let's make this a bit smaller. Smaller, please. 144. That's not called argstring. It's called. Oh yeah, because. Oh, const jar star. Sorry. Missing semicolon. Yeah, when I did that exit in, I've missed something. Okay. Right, that tells us that the files that the parser that we've added isn't actually present in the make file. Come on, move. So let's go to the make file, make this file. I just need to add in o.cli parser. Magic. Okay. Common command. I want to run af32.dis file. Put in quotes. Debugger. 0 plus 20. I only want to disassemble the first 20 bytes. Well, that didn't work. Oops. Let's have another look at that. So part of the problem here is that the disassembly code went and started trying to decode debugger as part of the numbers, and we didn't get the last one either. That's not right. Let's have a look back. So I think I should have added an extra 1 on the dis file increment. Oh no, I -2 there. That's one problem. And I'm actually skipping 2 arguments there, and I'm skipping 3 arguments here because I'm skipping 0, 1, and 2. 0 indexed arrays. You're all being very quiet. Completely unimpressed? Not at all paying attention? Not understanding? Oh dear! That looks broken to me. Okay, that's almost certainly because I skipped an extra parameter in here. What did we actually do here? Yeah, the watch was we read from 0 page, and so we read this dead value, and null pointer used is at 0 page. And the debug here tells us that we're still in main and that we were in this bit of code here. As you can see, we're loading single bytes at a time and doing some operations on it. Let's recompile that with the... Actually, mine was 2 there. Is that right? Oh, that's right. Probably right. Let's see what we get. Woo! That looks like it did the right thing. That's quite nice. At some point, I'm going to have to fix up these odd address offsets. I mean, right now we're okay because it's just like prototypey stuff. We'll move it into being like real stuff later. But we're going to want to do some of that. Anyway, dis file debuggers plus 20. So that works. Now can we try from address 20 for another 20? Does that work? I think that's right. That looks like it's doing the right thing. So, what happens if we try it on itself? af32.dis file 0 for 20 bytes. Now, what should happen here is it goes, no, nothing to print. Oh. Why did it do? Oh, that's why it did that, because this program, I'm an idiot. I've gone and tried to determine whether this is a absolute file by looking for a ~FF8 on the file name, which is correct when you're on not RISC OS, if you're on Windows or Linux or on Mac OS, as I am here, but it's not right here. What I actually want to do is to check the file type. So yeah, let's do that. Let's check the file type. Okay, so who can remember what the correct call is to read the file type of an object? Is it OS file 5 or OS file 13? answers on a postcard or answers in the PRMs. Was file 5. Yeah, I really don't want to find just the number 5. That's not very helpful. Search ROS file then. Do. 793. I think this must be a, yeah, this looks like it's got the right set of links. Ah, here we go. Read catalogue information from named path. That's not the one, because we need read catalogue information and file type. 13 was my guess. Read catalogue information for named object using path string. That's not right. Path variable. Extended catalogue information, 20. 20 is the one I want. Yep, and that gives me the file type in R6. Cool. See, I don't remember everything, or very much for that matter. File, get file type. Const jar star file name. Swix. Yes, I haven't included Swix yet. ROS file. Oh, let's have this in big size, shall we? There we go, bigger. 0, 1, 20. Oh, I also need to pull out the answers, don't I? Out. Okay. I need 0, which is the object type, and doesn't matter. Doesn't matter because according to the documentation, an untyped file. Oh no, non-existent file. Oh, is not found. Yeah, there we go. So it'll still return me a useful value either way around. So 20, I only need to get out R6 or the error as well. File name. And then the ampersand type, semicolon. Helps if you actually write valid code. If return type. There we go. Let's make this code work either way around. Or get file type, file name. There we go. So with that in place, oh yeah, and including swise. Oh, I already had include swise.h. Huh, cool. That's handy. Build it. Oh, yeah, no. Int type, there we go. Right, so that gives us the file type, and now we should be able to, when we try and disassemble an absolute file, it should say nothing to disassemble. But if I say disassemble from 8000 plus 20, it gives me that. If I say disassemble it with no details, and drumroll, come on. Yeah, just disassembles the entire file, which is kind of cute. Yeah, you can stop now. Thank you. Okay. So, we've now transferred that code into this file, and this file is working, which is quite nice. I'm going to commit that. Added implementation of the memory parameters to start this file. file with offsets. Interestingly, this is actually quite very similar to star DumpI. So if I go into PyDev, so it drops the command line on RISC OS, and then if we do help DumpI, so in case I've not described that properly, DumpI is the equivalent of star MemoryI, but for a file. And I've actually got a slightly different syntax here with an offset and a base address. But by using the same syntax that I had there, I've actually got a better implementation now in this particular tool. So what I'm going to do is I'm going to probably try and I think we're going to try and make DumpI. It'll have a slightly different syntax, but we'll make DumpI in the module. I know we're still working on MemoryI, but once we've got DumpI working, we'll have a lot more ease of which we can change things. Plus we'll have another command that works, which will be quite cute. So let us do this. Oh, hang on, I've committed the code, push it now. Yeah, so that's now going to be... Did you reload? Yeah, just been pushed. Implementation of the memory something. What's that? Memory? Yeah, memory parameters of this file. Cool. So I'm going to use the file operations here because I'm being lazy. I know I went to great lengths to go and avoid scanf, but I'm just going to be lazy here. And that will make some more sense later on with how I'm going to do it. I think it'll make sense anyway. Nose is itchy. Let's sneeze. No, I think we're good. So let's start moving some stuff around. Come on. This code here, this file down to here, all of this. Let's put this in a new file called what's this going to be? This is for disassembling files, but it's also going to be used for the disassembling of memory. I'll call it... Why is this... There are many things that are hard in computing. Naming is one of them. I'm going to call it... No, I can't call it this file. I've already got a tool called this file. I'm going to call it MemoryI. It's not MemoryI, but it will become that way. That's my argument, and I'm sticking to it. Okay, and then we call disassemble file exactly as before. MemoryI here has those in. Give it a declaration, MemoryI. Disassembly of memory or file structures, file objects. Yeah. Date today again is the 30th of June 2024. Hash include, what do we need? Come on, we need swise.h. We need string.h. studio. We're using printf here. That's all very well and good, but I've avoided using the scanf functions earlier, so I should probably start thinking about replacing those with more explicit system calls. I'm not sure it really matters at the moment, but it's okay, I think. Right, anyway, this is all very good. We just want to copy all of this into a new file called h.memoryi. Paste, delete most of it, because all I care about is the disassemble file. At which point I've noticed now that we don't have a file prologue description here. So this is disassemble file. Disassemble a file and print to the screen. File name points to the file to disassemble. Done. No, not 0 for starter file. Okay. And if def MemoryI I need, I also need include studint.h and get file types there. That could be a static function, but it's fine as it is. As I've created this file prologue comment, I'm just going to dump it back into here so that we've got a comment describing what the function does. Right, that's now there. I need to update make this file so that it uses this file. So we need MemoryI in here. I didn't need to do that. And then we build it again. Make sure it still builds. Or not. Prototype and alt type parameters. Line 33. C.memoryi. Oh, yeah. Include MemoryI.h. So MemoryI.h includes studint, which is why that was. But it's also good to include the file itself, because then any discrepancies between the header and the implementation get called out. Duplicate definition of get file. Does that mean that I left the implementation in the header file? I forgot to save the header file, so yes, I did. Ah, right. So we're also calling error, which is going to be terminal. Now, we can't do an exit 1 inside our module. If we do exit 1 inside our module, we'll get a very, very bad result out of it. And same goes for disassemble word. Not same goes, no, that just means I've forgotten to include a header, doesn't it? So I need to go hash include something or other. What do I include? Rodis, I called it. It might be a good idea if I changed the names of some of these to be a bit more descriptive, but right now I think we'll cope. Right. So we're still going to work because the error is still going to give us the right thing. I can just prove that by running it. in here. So if we do af32.disfile debugger from 0 to +20. Oh, we've also got the debug left in. I can take the debug out now. But that's still disassembling, even though it's using the additional library file now. So, important things. Let's take out the debug, since we don't want that anymore. And was there some more debug in there? No, I think that's our lot. Cool. And we can also do that. There we go. Right. I was just having a thought. If I ran the Pyro server here, I could actually jump in and out of running RISC OS things really easily. But I don't think I've got it in my path. Maybe I'll have a look at that next week and have a see if I can make that happen. It's not looking like it's got the right things. Oh, Pyro server. Was that actually working? Oh, okay. Ooh. Right, that's going to be a problem for next week. Not next week, well, whenever I do the next session. So Pyro server is, it runs the RISC OS in the background, and then you can basically attach to it, run a command, get the output, and then move on again. And you don't have the cost of starting up a new RISC OS. You also have the fact that this is a continually running RISC OS, so you can set variables and put things in memory and then look at them and things and jump in and out of it really quickly and easily. But I think that's going to be a thing for next week, because it looks like I need to do a bit more setup to make that nice. Sorry, an aside. What was I doing? So we've got new things added. So git add c/memoryi, h/memoryi. Those are now present. This tool will now work. So I can now go and say commit extract refactored the file disassembly into a new source. File disassembly in this file was largely standalone. Easily move it into another file, and then we will be able to create the start DumpI. Ooh. Oh, I ran the long line there. Let me just spin back and tidy that. Start that DumpI command in the module. That'll do. And it's now available for everyone. Or will be. There we go. Onto the pineapple juice. Tea's gone. Pineapple juice is yummy. So, as I mentioned, we've got a problem with this code in that with calling the error function in order to exit. That's not very nice because we can't do that inside the module. So we need to rework how that code's written so that instead of calling this error function, we can do something else. So let's go and look in here. And we've got two different error cases here. We've got file not found, and we've got, actually we've only got file not found. Huh. Well, that's kind of easy. What I'm going to do is I'm going to set up an enum that's got some error codes in it. So type def, oh, come on, type def enum I wonder if this is because I'm looking up a lot more and I'm missing the keys because I'm not able to look down as easily. No error. This error file found. And we'll call this disassemble error T. I'm a little bit disappointed that I've not got more done today. I think I spent a lot of time trying to sort out that parser, which is a little disappointing. There's a reason why that works. It's not like it's a problem per se. It's just one of those things that's like, no. I had hoped to get on to doing the other parser, one of those. The other bits of the implementation, but I haven't done that yet. So return this error file not found. And when we get to the end, return this error none. There's a place where we go to there, isn't there? Oh, actually, we could do no data or something. If you request something that's just nothing. I'm not going to return no data. I'll leave that. You asked for something for a range that was outside the file. Thank you, Alan. You said that done excellent work today, coming along really nicely. It's at least moving. Right, so having implemented this, I now need to put this in the header. So let's go to header file. Boom, boom. There we go. There's the declaration, and I need to go and copy this chunk here. To here. I'm also going to just tidy this up a little bit and put that there and do the same on the other side, just so we've got a little bit nicer declaration there. Okay, so that's got as an error type. That error type needs to be handled in here. Yeah, this file's all looking a bit ugly now, but that's not a problem. Trust me, it's not a problem. Yeah, that'll do. If found okay, so this file should still now work exactly the same. Yeah, more pineapple juice. Right, that was my tool that went and disassembled part of it. Let's just try that. That should still work exactly the same. Squeaky. Excellent. So I know I mentioned it before, but the reason for moving into using a program like this inside regular ARM executable AIF file, absolute, is that if something goes wrong, if we crash something, we'll get a backtrace, we'll get a bunch of details out of it. And we can even use this as part of our testing to check that the fundamentals are working without having to load a module. Because the module will execute in SVC mode, you'll be able to write all over the place. You'll be able to do a whole bunch of other nasties. And so implement it first inside regular absolute, and then move on to writing it inside the module once you've got it working. So, what have we done now? What have I actually done? Oh yes, so I've just made the error handling better. Yeah, that'll do. Fixed error handling in disassemble file to not exit. Boom, boom. Right, nicely checkpointed. Oh, and push it, otherwise nobody sees it. So, now, I know I haven't implemented MemoryI, but let's implement, DumpI. And unsurprisingly, it'll take very similar parameters. Oops. Oh, in case anybody cared, this is using my CMHG syntax mode for Sublime Text. There's a dedicated RISC OS CMHG syntax that you can use, which gives you context colouring of all of the tokens that are in a CMHG or CMUNG header file. This DumpI is going to be quite powerful, really. It's going to be quite nice. And it's an interesting side effect of what we're actually trying to do, that it's just like, yeah, we now disassembles a file. Slightly different syntax to what the DumpI had previously, but it's okay. I've added an extra parameter though, so this is going to be 7 maximum, but we do have to have 1. That looks good. That looks just fine. So, if I build that now, discuss ammo, not the file, the module. Failed to find, expected a bracket at CMHG mod headline 4. Does that mean I've forgotten something? Anybody remember CMHG syntax better than me? I mean, almost certainly. Do you need them comma separated? Maybe they don't. Maybe they aren't comma separated. Maybe they're just. Oh, I don't know. Let's have a see. Let's have a see if that works. No, I think it was the trailing comma that confused it. Yeah, it was the trailing comma. So you can't leave a trailing comma down there on the next keyword arguments. So yeah, no big deal. So if I go back to whatever it was, veneer, this is where we were up to. And if we have a look in, actually mod header I wanted, don't I? So this is the module header, and we can see that there is another declaration here for command DumpI, which we can just copy out and plonk into the veneer. So if you were doing it the traditional way with CMHG, you'd be putting them into this mod command, and you'd be checking the number to see whether the command number matched up against one of these comes MemoryI, comes DumpI values. And then you'd dispatch it to a function, or you'd handle it in line. But I don't like doing that. That feels a bit tedious. It feels like you're having to do a bunch of work that can already be done inside the veneer, and that's why CMUNG does it that way. When Robin and I wrote it, mostly Robin, it was a case of we'll just put as much as we can into here of the pain that we've had in the past, just to make our lives easier. and then we'll not have to fight things quite so often. So this isn't so good because the very first parameter in it is the file name. So I need to process the file name off it first. All I've done here is I've just copied the entire function definition from MemoryI because I want exactly the same parsing, but I also want to handle the file name. So let's just go into here. So const char star file name. So firstly, let's skip some spaces. If anybody's wondering, you could also write this code like this. Like this. However, if you write it that way, not only do you skip over the space, which may be useful, but you skip over the space, but also that semicolon is hard to see. And therefore you might find that you're not actually noticing that that's the case. Additionally, you could do it that way, which would then be a little bit more obvious, but you're still skipping over the space. And that's something of a problem sometimes. In this instance, that's exactly what I want. Not skipping over space. Actually, probably that's just fine. I mean, it's really just the semicolon thing. Skip leaving spaces. So in theory, we could also have reached an end of line here, but because we've got the minimum arguments as being 1, we must have a file name there. We know that the OS will never pass us an argument string that is not one thing long. So we can say that file name is always going to be here. And then we just need to find where the next space is or the end of the string. So whilst argstring is not equal to a space, or it could be a control character. So actually we can just say is greater than space. So as soon as we get to the space or a control character, we will stop. And then that will allow us to pass the architecture and the memory parameters, and then we can just go and call the disassembly function. And we do that in exactly the same way as we did here. What we can do here is copy that chunk there. Now in this case, we want to pass in thumb as a variable rather than as a the parsed architecture. Just because of that, I'm going to be a little lazy because yeah, I'm just going to do this parsed arc dot arc equals arc thumb 1 or 0. Later we can go and pass in the parsed architecture structure and it will make things a lot easier. Disassemble file name is that start. Start. Now start is part of memory args. So we'll just go down here. Actually, let's put all of these down on extra lines so they're a bit tidier. So this is start is memory params dot base address, and then this is memory params dot end. Oops, I pressed down instead of right. Error file not found. That's not going to work inside the module. What I'll do instead is I'll just make it do printf for now. Go back over there, build the module. isn't defined. Well, okay, let's define error. This is a dis error. I don't know what it is actually. MemoryI, isn't it? Disassemble error T. There we go. Don't think that worked very well. I'm betting any money I forgot to include. Yeah, I forgot to include the header. Include MemoryI.h. Qualify losing implicit cast of pointer at 159. File name is a constant. Ooh, that means that disassembled file is taking a char star, and it shouldn't be. It should only be taking a const char star. Where's that? It's in MemoryI, isn't it? Yeah, that should be a const char star, because the only thing we're using it for is just to pass it into things that never write to it. Oh, and of course I have to update the this thing, the header file as well. So const char star there as well. And again, we need to update the make file for the module to include MemoryI. Dum, dum, dum. We have a module. That's always good. Let's one of these blooming commands. Load mod. There we go. That's that command. That's a good one. Help debugger. DumpI debugger. Looks good. Only dumped a bit of it though. That doesn't seem... Oh! Right. So, sorry for banging on the table, getting excited. It's the code here. So in DumpI, I copied the code that was from MemoryI. So MemoryI will dump just a small segment of a file by default. Here, we actually want to dump the entire file. I'm going to make it a big number, but not a massive number, because if it was 8,000, it would end up with the values being back to front, and it would then go and do things wrongly. I don't want to overflow, basically. So, actually, what I could do is suspend that, build the module, foreground that rm load of rm32.debugger. Oh, all right. Apparently recognize that as an escape. No matter. So I've got the debugger loaded, and then I can just do it again. Right. And so now we're getting the entire program dumped. So if I press escape, nothing happens. And that's because there's no checks in our code to see whether somebody's pressed escape. In the absolute file, it didn't matter because the system that was put in place by the C library installed handlers for the escape and then could terminate the program. See, there's a whole bunch of really strange instructions there, like raws and the like. These are the test instructions that are in my debugger program. In fact, I should probably run that to see what it comes out like. Actually, that might be quite interesting because it will actually do something useful. Alan's off. See you later. Have a good afternoon. It'll all be available online for you later if you're really interested. How long have I been going for? Is it stupidly long? 2 hours 20. Okay, well, we'll get this finished. Oh, I think I'm going to have to kill that because it just keeps going. Bye-bye. All right, so one of the things we need to do then is inside the MemoryI routine, we need to check for escape. So how do we check for escape? We call read escape state. I think it returns the value in C, because that's not at all annoying. Checks whether escape condition has occurred. C is set. Well, okay, we'll use that then. So here we go. We've got the get file name thing. We've also got a int is escape pressed underscore swix read escape state. Oh no, not underscore state. Escape state. Not underscore out. Bracket underscore flags. I think it's underscore flags. Ampersand uint 32 underscore t. No, value. Sorry. Flags. If we get an error, we'll say the escape is pressed. Otherwise, if flags and anybody remember what the C flag is? Is it actually defined as underscore C? I think it might be. One. Actually, we can. I think that actually works. Oop, and I missed the semicolon. If is escape pressed, break. Build it. Run. Okay, there we go. Loaded the bit up. Come on. Now, start DumpI. Right, it's DumpI Debugger. All right. There we go. Now press Control C, and we exit, and we get an escape. Do I need to clear the escape state as well? Oh, I don't know. I suspect I probably do. Hang on. It should be acknowledged using OSByte 126 or cleared using OSByte 124. Acknowledged, I think, generates an actual escape. Cleared just says, no, it didn't happen. Yeah, I think I need to use OSByte 124 to clear escape. So let's just put that in as well. Void clear escape. That's just register 0. 1, 2, 4. Clear escape state. And I'm calling those Swix, but I'm ignoring the results because there's nothing we can do about it anyway. And we'll just put that into this part of the code here. Suspend that, build, foreground, load to .debugger, and then dump debugger. Control C for escape, and we don't get a escape notification. Good. Good. That's another good checkpoint, I think. Yeah, so we've added in *DumpI to the implementation. Okay, and push that so that people can see it. Okay. Ooh. Right. Okay. So now we've got a function here that can disassemble a single file, and it prints it to the screen. And we also know what address we're dumping it at, and we're dumping only part of the, able to dump only part of the file. Hang on. Messages. Maybe I wasn't paying attention to things. Give me a sec. Telly's just asked what my future project is. I had some idea for my future project, which was doing a little bit more on how oslib works, and I think I can do some interesting bits with that based on what I've been learning about things. It's going to be a bit more involved, but it's definitely a future one that I want to do. Might do it online, I might do it separately, not sure yet. Right, I'm not going to be much longer, I think. I think I'm just going to try and get the actual MemoryI, you know, the thing I was starting to do when I opened today, get that working, because I don't like leaving it unfinished. The bit I've done is quite nice, but it's not what I wanted at the beginning. So MemoryI is exactly the same as DumpI. It does the same thing as dumping a file, but it does it to memory. As such, he says, things like reading a word here, or reading a chunk here, and searching in part of the file are all things that are common, but are just need to be done slightly differently. So what I'm going to do is I'm going to create an accessor object. Memory data accessor, because it's not memory and it's not file. Oh, it needs to be an S, so it's just structure. Right, so all being well, this will probably be another 40 minutes or so, he says, and then I'll be done. If anybody's trying to get away or anything, if you're not, then that's fine. If if you are trying to get away, it's always there for you later. So uint 32 underscore t. Is that how you write it? I don't remember how to write function prototypes. I think that's right. Ah, no. Nope, 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 nope. Doing it wrong. Oh, dear me. And then I can use data accessor. Yeah, address. Actually, do I want... I'm trying to make it into functions that are similar to the ones we've got here. So if I say, if I have an eoff there, I could have something that says, are we done? Or do I want to say, read the end of, read the limits? I think it might be easier just to have a read limit. Oh, maybe it should just be a constant. Oh, there's a thought. Start and end. So we could actually put start and end in the structure, and then instead of actually checking whether the end of the file, this becomes implicitly done that way. That'd be quite nice. So that's reading Word. We probably want one to read a byte as well, because we do some... Oh no, we don't actually read a byte here, we just do the extraction there. Yeah, that's okay. Oh, actually, we don't even just read a word, we read a block, don't we? That's actually what we do. It should be the amount that we read, shouldn't it be? So this is a function called readBlock, which will take itself as a handle and pass in the address you want to read of the logical object, the data, and the size for where you want to put it. So we no longer need that there. We can replace this with a data accessor T. And this becomes setup code. Hang on. Yeah, I'm thinking. I'm trying to work out what the right way is to do this, because disassemble file is actually quite a nice little interface. So why don't we keep that interface and move things into here that we actually want? So what we can do is we can do the file opening and the address calculations there. Those are all quite nice. I'll put those in there. Oops. That becomes implicit. This here becomes the block read function. Let's just copy that up here so that I can use it in a moment. I've lost it. Oh, there it is. So this is if accessor to read block bracket. Well, I've already forgotten how I defined it. Oh, accessor itself, comma, address data size. Oh, hang on, that shouldn't be a star. Actually, you didn't think. Don't know what I was thinking about that. The address, where to put it, which is ampersand word, and the size is inst size, and the size is going to be returned as inst size as well if it's successful. And then all extraction should work okay there, and we don't need to do anything else with that. This fseek is irrelevant because we're going to do it implicitly. So int read block bracket data accessor handle int t address data int size struct file accessor. This is a data accessor. And it is a followed by some of the parameters that we want. So we want the file star f. We want a uint 32_t base address. I think that's it. Oh, well, probably a current offset. Current pointer. If current pointer is not equal to the address that was requested, oh no, uint 32t offset file putter. The file pointer we want is the address minus. I'm sorry, this is probably not going to be making a lot of sense. Right, so I'm creating a file accessor that is a superset of the data accessor and has some extra information associated with it. And then I'm going to go and use that extra information to go and access the file as well. So this is the, I'm just going to call it file here actually, equals file accessor. Handle. Fingers are sore. File pointer is address minus file, oops, in the wrong place, file to base address. So that's the actual file address. So if if the base address of the file is 8000, we then know what the actual file offset is. If the current pointer is not equal to the address, then we need to do a seek. We'll need to do a seek on file to f. The address is good. I'm glad you're still following. It's I'm finding myself being a bit confusing myself here because I'm trying to think on things. And so the offset is the file putter. And that should be file putter there. So right. I want to read this into data. Right. The new file pointer that we have just set ourselves to, the new current pointer, sorry. Current pointer is in file to current pointer. Equals file putter. There we go. So that moves us to the right place. Then we do a read of the number of bytes into the data block, and we want to know how much we read. Read equals that, and then the file pointer will have incremented by that much. And we return the number of bytes we read. Okay. Oh, except I've only defined this as a struct. Type def. Disassemble file. Open it there. Right, we can create a file accessor _t here. Call it file. And then we start assigning stuff. So file file to f equals assign the file. File to base address equals address. Address needs to be defined. Uint 32 address. File to read blocks equals, oh, this should be called file read block here, shouldn't it? And it's actually read _ block. And we also need to know how large the file is. So I need to fseek f. Oh, I've forgotten how fseek works. I copied it up here, didn't I? There it is. F file, the pointer, and then the address. file, the pointer 0, seek end. Seek to the end of the file. Then ftell, tell me how big it is. Which I should probably write into the structure here, which I've lost. There we go. uint 32 underscore t file size. File to file size equals that. And then we'll just jump back to the beginning again, so that we know where we are. Also, since we have just set it to the beginning, we should say file to current pointer equals 0. So we've got current pointer initialized, base address initialized, file size initialized, f initialized, data initialized. We just need start and end now. Do I need start and end? A start and end part of the accessor? I don't think they are. No, they're not. Start and end are parameters that we use, that's all. So if address, well, file to base address plus end is greater than file to file size, end equals, oops, got an extra S on there, file to file size minus file to base address. Right, so it won't go beyond the end of the file now. If the start is greater than the end, then make the start also be the end of the file, which will cause it to end pretty rapidly. And then call disassemble stuff. Handle. Data accessor. Dum 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 dum. Zero. Why is that all coloured wrongly? That means I've left this bracket open. So it is a data accessor called file. Actually, I've just realised I've done this wrong. I've accessed all of these with arrows rather than dots, because it's an object in here, not a pointer. Let's do that. Dot. It's kind of frustrating that the distinction is made there. I understand why, but it's like since you know what the type of the object is, it feels like you're making your life difficult even still. Dot. Oh, and one more there. Because I mean, it doesn't make sense to do file arrow. I suppose it does show you like that you're knowing what type of access you're going to do. Oh, and of course at the end of this file we need to do close, but that's not a thing for that, it's a thing for this. Return error, because what's it called? I've lost the thing. This one here. One of them is what's going to be returned. Right. Now, the problem with this is that disassemble file is now before this one, but it calls the disassemble stuff. So let's go and put disassemble file there and ensure that this is actually called disassemble stuff. Struff even. And then see whether it compiles. It almost certainly will not. Line 68. Oh yeah, that's because it's file to F there. Implicit cast of non-zero int pointer, declared name accessor, line 106. Oh, because actually I've not called it handle, I've called it accessor. We'll change it to that then. That's fine. (106) read block should be read underscore block, and file accessor here has no read block. 176. Oh, that's because that should be data dot. Implicit cast of pointer to non-equal pointer. I've got my pointers wrong. What's the other one? 186. An arrow. Yeah, I used an arrow where I should have used a dot. And this is where wrong number of parameters to stuff. Really? Oh yeah, because I didn't pass half the parameters. And the thumb, and the start, and the end. Thank you. Right, so we should be down to just one mistake now, which is my function pointer that's come out wrongly. File read block, which is up here, is an int file read block data access handle. Isn't that how you write it? Is it that? No, that's not right, is it? What? How is it I've forgotten how to write these blooming things? Hang on. Hang on. Is it as simple as I'm meant to pass in that? Is that what it is? Implicit cast of pointer to non-equal pointer. I don't have that installed. So many times do I write things with function pointers in the past, and I'm now forgetting how to do that. How do I declare a function pointer in C? Well, that looks like I got it right. Yeah, that's right. Oh, go away. Blooming pop-ups. So that was right. I'm feeling a bit stupid now. Come on. Anybody else want to say why I'm doing it wrong? Has it been too long since I've written any C code to know what the heck I'm doing? Is the error telling me something different to what I'm thinking? Implicit cast of pointer to non-equal pointer. Function argument. Arguments? 106. 106, completely different line to what I was thinking of. It's the accessor function, a data pointer. Wasn't my assignment. The address, which is a uint32. Oh, hang on, my word there. Right, this should almost certainly be uint 8 underscore t star. And I should have that declared as a uint 8 underscore t star in the other bit. It helps if you can actually read the error message. Uint 8 t star. There we go. I mean, it could be a char star, that will actually be the same thing, but it'll be correct this way. Okay, after all that, I should still have a working DumpI. That's a lot of work to just get to that point. Well, there's a possibility I may have got that wrong. And that's because I've just spotted it here. I'm returning I'm writing into the pointer, not into the. Okay. Build the module. Load the module. Try it again. Hey, that looks more like code, doesn't it? Yeah, that looks all right. Right. So I now have a file dump, which is nice. Status. Commit -a. Right. Disassemble underscore file is now able to use an accessor. Instead of talking directly to the file, which will allow us to place the reading with a memory interface. Okay, let's just do the memory interface now. So, to do a memory interface, we have exactly the same chunk of code, but for memory. Memory accessor. Uint 8 underscore t star data. There is no such thing as a size. I mean, we probably will end up with a validator function, because at the moment, if we try and access anything that is invalid, we'll get a data abort, which would be bad. But That's going to come next time. I'm not going to get that done today. I thought I was going to get it done today. I was clearly too optimistic on that. Memory. Right. There's no such thing as a base address when we're doing it with this. You don't have to do that. We just do a mem copy. Oh dear, yeah, mem copy. It's dest source, I think. So dest is data, source is address, which we probably need to cast to a void star, and the size is a size. See you on bytes. Have a good evening. Read memory block done. Okay. Okay. Now disassemble file. Disassemble memory. And all we have is a start and end. We don't actually have anything else to assemble because it's going to be as it stands. Assemble memory. Open to the screen. All right. Instead of a file accessor, we need a memory accessor. We don't have a file star. We have no base address or anything. We can't return that. We can't do that. There's nothing there. We probably don't want to call the memory accessor file. Let's call it mem. Mem. Memory read block. None of the rest of this is valid. Use the close. And we're done. So that now should be able to disassemble memory. Whether it works or not is another matter. However, I also need to copy this into the thingamy. What's it called? Header file. Oh, I didn't copy. Come on. To there, please. Copy. MemoryI. And then go into the veneer, and this segment of code here can now be dropped into here without the file name, obviously. And we can lose some of this debug as well. And that should be... Ooh, I forgot to push. Terrible. Duplicate member data. Oh, yeah, I know what that is. That's me being stupid. I've called the... Where's the memory accessor gone? Here we go. Memory accessor. Data. Yeah. Call that memory instead. Ooh. Huh. Actually, we don't even need that. We don't need any memory because our memory is just what it is. It's just going one-to-one mapping. Under thread name int return. Oh yeah, so we read size. Yeah. And that. Yeah, we don't even actually need the memory structure here. It's to be called mem, not undeclared naming to inventing int file. That means I've used it wrongly here, I think. Hang on, a bit bigger. Yeah, it should be called mem there. In veneer 11. Yes, this is because we've got some slightly different things in this. I need that one, don't I? In theory, no. 170 implicit cast of non-zero int to pointer. Oh, because I'm still calling disassemble file. Yeah, that's why. Disassemble memory. And hang on, I've got still one running, haven't I? There we go. Star rm load DumpI debugger. So the dump still works. And now we should be able to do MemoryI as well. MemoryI 8000 plus 20. That seems to work properly. It may have taken a while, but I got there. So star modules. So MemoryI 70254. That one there plus 80. Oh yeah, that wasn't the right spelling. MemoryI. There we go, there's the head of the module and then the debugger module appearing. Well, that was a bit harder than I expected, but the reason that it took so long was because I went and separated out all of the functionality that I already had into relevant objects, functions that I could then reuse, and then I used exactly the same function for the disassembly of the file in the disassembly of memory with just a slightly different set of accessors. So this also means that if you wanted to disassemble a module and set the address to be 0, you'd just need a memory accessor that had a slight offset on it. So it set that up as a different way of accessing it. Or you could have access a file that is on another machine or something like that. You could do. Why you'd do that, I don't know, but you could. And when we come to implement star memory and star memory A, we might actually do the same thing and use the accessor to go and get the data, which will make it a lot easier. All right, that has taken a long time. I'm going to quickly commit it. Yes, Andrew says why well-managed and reusable code is the best way to do things. Not only that, but if I wanted to write test code for this, I can then test just the parts that are separated out, and they would hopefully work, and I'd only have to test one function, hopefully. Yeah, that's the idea anyway. What do we do? Oh yes, this is add implemented MemoryI, which as Andrew also mentioned was very quick because it was basically just wiring up a couple of little bits. Implemented star MemoryI using the accessor functions. Module. All right, that's done. And with that, this branch is now complete. We have added the MemoryI command, so I can check out master, and then I can go and merge, add MemoryI. I'm going to do it with no FF, so that we actually get a merge commit in there. Yep, there we go. And we can push that, and then you'll be able to see it. All right, that's enough for today. I apologise for it taking slightly longer than I anticipated. Oh, I said 40 minutes to add the MemoryI implementation, and I think I about hit that. That's not bad. Yeah, feel good about that. I'm liking the fact that we've managed to get that working. I think I might do one next Sunday. I'll have to decide, but I think it might be next Sunday. All being well, we'll have some more interesting things. I'll try and think on better ways and things of doing things so I get a little bit more interesting a session. thank you everybody for watching. If you want to leave any comments, please drop me an email. I'm happy to take emails. Yeah, it's Andrew says marathon session. Amazing to see you pull it off live. Well, yeah. I'm sorry. I think like last time, I spent a lot of time talking and trying to explain what I was doing as I was doing it. I don't feel that I did quite as good a job on explaining the accessor functions and why I was moving things around. I hope it became more obvious as we got towards the end. Hopefully I'll get a bit more practiced at trying to do some of this stuff. It'll be a bit easier in the future. But right now I think that's yeah, a good place to stop. We've now got a merged branch onto there, and we can now do that. MemoryI works. All right, see you all later. Hope you have a good whatever's left of the weekend. It's 5:10. And stay cool. It's not too bad here, but warm in other places. Bye-bye. Oh, yeah. Like and subscribe. I think that's the thing you've got to say. I don't care. It's fine. Bye.